this video, we'll continue to go over different compressor model types available in VapCyc. For information on the following compressor models, please refer to our other video on VapCyc compressors on our Optimized Thermal Systems website. The 10 coefficient database compressor model version 3.0 is an earlier version of the 4.0, and VapCyc includes sample templates that a user can use or modify to use for this model. These are located in the same sample performance data folder as the templates for the 4.0 models. The example we are going to be using is called Database Compressor v3_template. Select the specifications for the compressor and change the efficiency and power correction factor as deemed necessary. The Tandem Compressor is a map-based compressor that still uses AHRI 540 standards. This model uses database files, and the user can browse for a database file. In this example, we will be using the database file called Database Compressor version 4_10coef_template, and not the Excel file with the same name. Select the model for each compressor by clicking on the box with 3 dots, and change the efficiency and correction factors for each compressor as deemed necessary. The 3-port 2-stage split compressor model with intercooler option is essentially identical to the 2-stage compressor model with intercooler option, which is covered in the previous VapCyc compressor video. The Edit Properties window that appears when this component is selected is the same as for the 2-stage compressor with intercooler option. The compressor with Economizer Port is, as its name implies, a generic compressor with an economizer. In this model, the displacement volume, low-stage volumetric ratio, volumetric efficiency, RPM, and isentropic and mechanical efficiencies can be specified. The generic scroll compressor with shell heat transfer takes into account heat transfer out of the shell of the compressor to the ambient air. Additional heat transfer due to a partition or shell conduction can also be specified. In this model, the efficiencies are assumed to be constant. The Compressor Properties tab allows the user to enter displacement volume, RPM, volumetric efficiency, isentropic efficiency, motor efficiency, heat transfer areas, motor location, and heat transfer coefficients on the high and low sides. The generic reciprocating compressor with shell heat transfer is similar to the generic scroll compressor with shell heat transfer, but with the capability to input more information about heat transfer area and heat transfer coefficients on the inside and the outside of the shell to account for additional heat transfer. Once again, the efficiencies are assumed to be constant in this model. The generic compressor with efficiencies equation inputs model is also similar to the generic scroll compressor with shell heat transfer, but a user can specify isentropic and volumetric efficiencies using fixed values or equations. These equations should be in SI units. Mechanical efficiency can also be specified.